Hello students. Today we're going to talk about two things that we just haven't really fit in yet. The first is the vertical line test, and then the second are piecewise defined functions. The vertical line test is really neat because it's a way for us to check whether a relation is a function or not by looking at its graph. I'll give you the definition of the vertical line test, and then we'll look at some graphs. The vertical line test says a relation is a function if and only if each vertical line in the plane intersects the graph at most once. Let's look at a few graphs. We will use the vertical line test and we'll talk about why it makes sense. We'll start with y equals the absolute value of x. If you look at a vertical line, you can see that it only intersects the graph once. And this is true for any vertical line that we can draw. You could draw 1,000,000 vertical lines through this, and each one would only intersect the graph once in one place. And so what that means is, because each vertical line in the plane is intersecting the graph at most once, it is a function. So yes, this is a function. Let's take a look at another example. Here we have the circle x squared plus y squared equals 25. If we draw a vertical line that goes through the circle, for example, this one, we can see that it intersects the circle in two different places. Because of this, this fails the vertical line test, and so we know it is not a function. Let's talk about why this is the case, why this means it's not a function. If we look at this vertical line, we see that there are 2 points on the line that intersect with the graph. These points have coordinates -4, 3 and -4, -3. I know my graph isn't quite perfect. My point is a little bit higher than it should have been. I can't draw a circle perfectly with my hand, but those are 2 points on the same vertical line on that curve. Now, if we look at these in the context of a table of values, we know that the first point corresponds to x equals -4 and y equals 3, and the second x equals -4 and y equals -3. This represents 2 different output values for one input value. And remember that when we have a function, each input value is only allowed to have one output value. So we know this is not a function because we have one input value that has multiple output values. And graphically, this is represented by 2 points on the same vertical line, because both of these have -4 as the input, but one of them has 3 as an output and the other has -3 as an output. So anytime we have a graph where a vertical line intersects it more than once, we know automatically it is not a function. Let's take a look at a couple more graphs. Here we have y equals x squared, a parabola that opens upward, and here we have x equals y squared, a parabola that opens to the right. One of these is a function where y is a function of x, and the other one is not. Which of these is a function? Specifically, which passes the vertical line test? Well, if we draw some vertical lines on the first graph, we can see that all of them only intersect the graph in one place. This means it satisfies the vertical line test, and y is a function of x. But in the other graph, if we pick a vertical line, it goes through the graph twice, and so this means that it does not pass the vertical line test. It fails the vertical line test, and thus it's not a function. One final thing to point out. There is one line, one vertical line in this plane that does only intersect the graph in one place, specifically the y-axis. That only intersects the graph in one place. That doesn't mean that it passes the vertical line test, because it says each vertical line in the plane has to intersect at most once. So we can't look at a single vertical line and conclude from that that something is a function. We have to look at all the vertical lines, and if even one of them intersects the graph more than once, we know that it doesn't represent a function.